31 of Neetcode 150. Find minimum in rotated sorted array. All right, so we might gonna say, hey, we just have to return basically, right, so we can simply return a minimum of the nums, right? There you go. But the thing is that they're asking us um, to find an algorithm that runs in log n of time, and we know that what runs in log n of time is binary search. Okay, so this is way too simple, especially in Python. You basically write like 3 characters and you get the answers. So let's go on the blackboard and see how we can solve that. So let's say that we are given 1, 2, 3, 4, 5, 6, 7 as the input. Basically, when they mean that there is a rotation, they basically just mean that they took the first number and put it at the end. All right. So if I tell you that there's been 3 rotation, there's been 1, there's been a second, there's been a third rotation. Okay, that's really it. And with this, we have to find the minimum number. So how can we actually find a minimum number? Let's say that we have a fourth rotation. Okay, so let's use the binary search algorithm. So we're gonna have our start pointer and our end pointer, and we are gonna take the middle value. It is 1. Okay, and 1 is exactly the target, so you will return 1 right away. So let's make it a bit harder. So let's just have 3 rotations. Okay, so we have our start pointer and our end pointer, and the middle value here is for 7. So the thing that we want to do is basically to check if that that middle value is greater or smaller than the value at the top right. Well, if it is greater, it must means that the start of the string is to the right. So at this point, we will forget about the left part of the array, and we just put our left pointer here to one array to the right and start looking at here. We have a 2. And I didn't specify it, but let's see that the target here is 1. Okay. All right, so now it makes a little bit more sense once we know what we are looking for. So we know that 2 here is actually going to be it is going to be smaller than our right pointer value. So what we're going to do is that we are going to cross the right side, but we're not going to cross the middle value in this case. Instead, we're going to put our right pointer exactly at a place of where the middle was. All right, so now we can continue our search with this very array or sub array, and we are going to find 1 as the target. All right, so basically the logic here is that we are checking through the array, and if the value that we have is greater than the value of the right pointer, we are going to move our left pointer by 1 to the right of the middle. Otherwise, we will set our right pointer at the middle value. So let's just see one final example before we jump to the code. Let's say that there's been absolutely no rotation at all. All right, and we are still looking for the 1. Or no, let's say we are. Yeah, let's say we're looking for the 1. All right, so first we're gonna look at 4, and we are gonna see that 4 is actually smaller than or right pointer. So we are going to set our right pointer at the middle value, and we are going to basically forget about this other side that lies to the right. Our left pointer is still here, and after this, our middle value is going to be the 2, and the 2 is still smaller than the value at the right index or the right pointer. So we are going to set a right pointer to the middle value, and we're going to forget about all the values to the left here. And finally, we are going to find our smallest value, okay? Because eventually the right pointer is going to be equal to the left pointer. So we're going to get out of the loop, and we are going to send back 1. All right, so let's get started. Then create or start and end pointers. So the start is going to be equal to 0, and the end pointer is going to be equal to the length of nums minus 1. All right, and now basically we're going to loop while the start is smaller or equal to the end. And we're going to set a middle value equal to the start plus the end, the integer division of 0. And you want to know basically if the start is equal to the end, this is our clue. Well, this is our clue that we have found the smallest number. So we will return that smallest number at whether start or end. At this point, they are the same. Okay, so this is our sole return statement. The other condition in the problems is, what if basically the number at that middle value, what if it is greater? So what do we do if this is greater than the value at the right point here? Well, we are gonna set our start to the middle plus 1. And the other possibility is that the number of the middle value is smaller than the value at the right pointer. So in this situation, the and, or I wrote R here, but it really is and. So if basically this value is greater than the value at the end, we are gonna set our start to the middle plus 1. Otherwise, the middle value is smaller than the number at the end index. So in this case, we will simply place, or we will say that our n is equal to our middle plus no need to add a plus here. All right, so this is the entire algorithm, and everything should work just fine. So let's run the code, and it worked. All right, so this is how you can apply binary search in finding minimum numbers. It is definitely more efficient than using the maximum method that will look for each values with a time complexity of big O of n. So this one is using a time complexity of big O log n, which is much better. So I hope you learned from this video, and I hope to see you in the next one.